All right, so here I've got a matrix A, and it's reduced row echelon here. So let's first find the rank, which is the dimension of the column A, and the dimension of null A. So I noticed I've got 1, 2, 3 pivots. So rank of A is equal to 3. So the dimension of null A will be the number of free variables. So there's 6 variables total, and there's 3 pivots or basic variables, so there must be 3 in the 3 free variables. All right, so basis for column A is the same thing as just saying find column A. So I've got my 3 pivot columns identified by these basic variables. So I go back to the original matrix and I pull out those 3 vectors. So I'm going to pick the fifth, which is 3, 0, 3, 3. So these 3 vectors are the basis for column A. The basis for row A, I'm just going to pick the 3 rows. So 1, 0, negative 3, 0, 0, 3. The 3 pivot rows. And the last one, 0, 0, 0, 0, 1, and 0. Okay, so those 3 rows are the basis for row A. All right, so null A is the one that takes work. You're expecting it, right? So I'm going to just say bx equals 0, right? And I'm going to pick out from the first row what I get. x1 minus 3x3 plus 3x6 equals 0. x2 plus x4 equals 0. And x5 equals 0. So these are my 3 basic variables. So I'm going to solve for them. Okay. So remember, I'm always encouraging you to just take the time to write this. 4, 5, oops, 6, right? There's 6. 1, 2, 3, 4, 5, 6. So I got 6 variables. So for x sub 1, I'm going to put in 3x sub 3 minus 3x sub 6. X sub 2 is negative x sub 4. X sub 3 is itself. X sub 4 is itself. X sub 5 is 0. And x sub 6 is itself. And that could be an easy one to miss, right? So if I pull out my x sub 3, I get 3, 0, 1, 0, 0, 0. Pull out my x sub 4, 0, negative 1, 0, 1, 0, 0, right? Each of these have to have 6 entries. And then my last, x sub 6, negative 3, 0, 0, 0, 1, 2, 3, 4, 5, and 1. Okay, so my basis for null A, which is this the same thing as saying find null A, is these 3 vectors. So it's necessary to kind of write them in this formal set. Negative 3, 0, 0, 0, 0, 1, and put the end parentheses. So that's my basis for null A. Okay, so here we go. 4 by 7. Okay, so it has rank 3. So that means there's 3 pivots, 3 basic variables. Okay, so rank A, 3 pivots. So what's the dimension of null A? So since there's 7 variables total and there's 3 basic variables, the dimension of null A will be the number of free variables. So that will be 4, because 4 plus 3 is 7. The dimension of row A is always the same as the rank. So that's going to be 3. And the dimension, or I'm sorry, not dimension, but rank A transpose, that's the way, a nice way of saying take the transpose and find the dimension of the column space. It's still going to be the number of pivots. So that's 3. All right, if the null space of a 4 by 6 and 3, 4, 5, 6 is 3-dimensional. Okay, so null space, if dimension of null is equal, null A is equal to 3, that's like saying that's the number of free variables. And if it's a 4 by 6, there's 6 variables total. So what's the dimension of the column A? Dimension of column A must be 3 because that's the number of basic variables that I must have left. Okay, so that means I have 3 pivots. I get that from dimension of column A equaling 3. So there's my 3 pivots. Okay, so is column A equal to R3? It does have dimension 3. Do the columns of A span R3? No. Elements of column A are in R4, so not possible. Different animals, right? Okay.